Algebra 1 Lesson 80, we are looking at frequency distributions and how we can show our different data with our bar graphs and also use that to find theoretical and experimental probabilities. So remember, discrete events, these are talking about a finite number of outcomes. The number of outcomes actually has a certain end to it. A simple event is one single event, such as like flipping a tails on a coin. A compound event is when we're doing a couple things, like flipping tails and then another tails. Frequency distribution shows the number of observations with ranges or data intervals, and it could be a table or a graph. We are just showing what is happening. So, for example, let's say we have two number cubes, and we are rolling both of them to figure out what sum do we get with the two number cubes. Okay, so we are going to, just in this video, talk about the theoretical probability of all of these. Now, we can get all of these different sums, 2 through 12, but their probabilities are not all the same, because getting a 2, I only have the option of 1 and 1 on the number cubes in order to get that sum of 2. Rather than like 6, I could get a 1 and a 5, a 2 and a 3 and a 2, a 4 and a... We have lots of different options here. Sorry, I'm talking about sums, not multiplication. Just got myself confused there. So what we should probably do is figure out, all right, what are the different ways that we can get each of these sums? So we need to make a chart with all of the different sums that we could get and say, all right, we could get a 1, 2, 3, 4, 5, or 6 on that first number cube, 1, 2, 3, 4, 5, and 6 on the second. And so we go through and add them up and say, if I get a 1 and 1, a sum of 2, sum of 3, sum of 4, sum of 5, 6, and 7. I'm just going to fill this in very quickly here. All right, so when we look at this, we see our 36 possibilities and with our two different number die, so that we can say, all right, what's the probability of getting a 2? Well, out of the 36 possibilities, there's only one of them that will make that happen. Whereas getting a 3, I could say that's 2 out of 36. For getting a 4, there are 3 different ways that I could do that. Okay, getting a 5, there are 4 different ways, which we can reduce here. Okay, we can reduce any of these. I'm just going to keep them as is right now just to show the pattern. Okay, a 6, there are 5 different ways. 7, there are 6 different ways. And then we start going down. Okay, 8, there are 5 different ways. 9, there are 4. 10, there are 3. 11, there are 2, and 12, there's only one way. So these are our theoretical probabilities as far as finding the sum for our two number cubes. So yes, we can reduce all of these into their simplest form. Now we could also put these in a bar graph to be able to show this is the theoretical probability. Remember that bar graphs, those bars do not touch. Okay, and we can also do an experiment for this, rolling our dice and seeing how does the theoretical probability reflect the experimental probability, or maybe it doesn't. Okay, maybe something was really different with your number die, but it should, after 50 times, get pretty close to this pattern, pretty close. Okay, so with those, remember we can do a bar graph. Remember, they don't touch. I'll show you a bar graph of what we're talking about in a different example. All right, and think about if you were to do this experiment, how would your experimental probability match your theoretical? All right, so let's look at a different example of how we can use these frequency distributions. So the table shows the results of each at-bat. Make a bar graph that shows the frequency distribution of the data. So we have all of these different at-bats, 30, 36, 29, 3, and 1. Let's see, all together, let me just add this up really quick, we want to know the total so that we can say, all right, what's the experimental probability, because we couldn't really find the theoretical probability for something like baseball, but we can find the experimental probability. All right, so we say there are, it looks like 99 at-bats. Let me check that one more time. Yes, there are 99 at-bats. So we can say that the probability of each of these events, all right, so we can say we have 30 out of 99, of course reduce, 36 out of 99, 20 out of 99, 9 out of 99, 3 out of 99, and 1 out of 99. Okay, so we can talk about those experimental probabilities of each events, but we can also show a bar graph. Remember, bar graphs don't touch, and so we have these buckets that we can be in. So we can talk about the outs, we can talk about the walks, we can talk about the singles, the doubles, the triples, and we can talk about the home runs. Okay, and for each of these, I'm going to show how often did it occur. Well, we have a total of 99, so we should show all of the different times that it occurs. So we want to go all the way up to 36. So I'm going to go by, let's see, 5s. Okay, so that we can see, all right, for our outs, there are 30 of those. So I'm going to take my bar all the way up to 30. The walks, I need to go all the way up to 36. The singles, there were 20 of those. The doubles, we only had 9. The triples, there were only 3. And the home runs, we only had 1 out of 99. Okay, so we can see the frequency distribution to show how it changes from outs to home runs. All right, another situation. Now we have a spinner and a coin. A student flips a coin and spins the spinner. Make a table to show the possible outcomes. Find the theoretical probability of each. So in this, we have 4 sections, red, blue, yellow, and red. And of course, on the coin, we have heads and tails. So to fill in the table, I could get a heads and a red, heads and a blue, heads and a yellow, heads and another red. And then we could get tails red, tails blue, tails yellow, and tails red, which means we have a couple that are similar. So when we're thinking about theoretical probability out of these 8, if we're thinking about the heads red, we actually have 2 out of 8 that are heads red. If we have heads blue, that only happens 1 out of the 8. Heads yellow is also 1 out of the 8. And then we think about our tails red. That also happens twice out of 8 times. Tails blue is only once out of 8. And tails yellow is also once out of 8. All right, and of course, reduce your fractions. So we need to make our tables to show how often can these occur. And I think this is my last example here. Make a bar graph to show the frequency distribution for a set of 11 cards each containing a letter from the word Mississippi. Find the theoretical probability of each outcome. Now we're looking at all of these letters and seeing how there's more of some letters than others. So if we look, M, there's only 1. I's, let's see, we have 1, 2, 3, 4. For S's, we have also 4 S's. And for the P's, we only have 2. So a total, we have our 11 cards. So we could say that the theoretical probability of each of these, M would be 1/11th, I would be 4/11ths, S would be 4/11ths, and P would be 2/11ths. And we could show this frequency distribution by saying we have all of these letters, Okay, we just need to show the unique letters, and then we will show the frequency distribution. So I'll go by ones to show that M only happens once, I happens 4 times, S happens 4 times, and P happens twice. Okay, so our frequency distribution of this data. All right, well, I hope this helps for your homework and for studying.